Large language models, they can write stories, answer our questions. They can even crack a joke with perfect grammar. And all of that raises this huge, huge question that we're going to tackle right now. So, are they actually thinking? Do they think the way that we do? It's such a fascinating comparison because when you zoom out, both the human brain and these LLMs are processing information through these super complex networks. We have our biological neurons, they have their artificial ones, and both can learn and get better over time. Okay, so let's really dive into this. All right, so we're going to break this down and compare human and AI thinking across 6 key areas to really get to the bottom of it. We'll look at how they learn, how they process information, how they remember, how they reason, how they make mistakes, and finally, this really important idea called embodiment. First up, how do they learn? And let me tell you, while both humans and AIs do learn, the way they go about it, well, it couldn't be more different. Okay, so at the heart of it, our human learning is super dynamic and efficient. And that's all thanks to something called neuroplasticity. AI, on the other hand, it uses a process called backpropagation. And that is way more rigid. And man, is it hungry for data. So, neuroplasticity. It's just the brain's incredible ability to literally rewire itself based on what we experience. You've probably heard that old saying, right? Neurons that fire together, wire together. That's pretty much the gist of it. And this process is insanely efficient. A person can learn a totally new concept from just a couple of examples. Sometimes you only need to see something once for it to stick in your memory for good. LLMs, though, totally different story. They use this completely artificial process, backpropagation. This means feeding a model millions, and I mean millions of examples from text. And with every single pass, it just slightly adjusts its internal settings to get a tiny bit better at predicting what comes next. So while you or I can learn a new word after hearing it just once, an LLM might need to see that same word thousands of times to really get it. And here's the kicker. Once it's done training, that knowledge is pretty much locked in. It's static. And this massive difference in learning leads us right into our second point, how they actually process information. And this is where we see this huge split between, say, grasping an idea versus just shuffling symbols around. Think about it. The human brain is just massively parallel. We've got billions of neurons firing all at the same time. When you hear a sentence, you're not sitting there decoding it word by word. Nope, you're grabbing whole chunks of meaning at once. We work on the level of ideas and concepts, instantly connecting everything to what we already know and the context around it. But in LLM, it works on a totally different principle. It takes text and chops it up into these little pieces, these symbols called tokens. And then all it's doing is calculating which token is the most likely to come next based on all the patterns it saw during training. It's like a super sophisticated game of what comes next, a form of pattern completion. But that is just not the same thing as understanding the actual idea behind the words. Okay, so we've got different learning, different processing. So what about memory? Well, as you might have guessed by now, the way they're built for recall, they're worlds apart.
See, human memory is this complex, beautiful landscape. We've got different systems working together: sensory memory, working memory, long-term memory. And our memories are associative. They're all tangled up with meaning and emotion. And in LLM's knowledge, though, it's just not like that. It's all baked into its programming, into its model weights, kind of like one giant static database. And its working memory, that's just the context window. The moment a piece of information scrolls out of that window, poof, it's gone, instantly forgotten.
Just think about our associative memory for a second. The smell of, freshly cut grass, or a certain perfume can just instantly transport you back to a specific moment, a specific place. That's because our memories aren't just data points on a spreadsheet. No, they're woven into the very fabric of our senses and our emotions. All right, and this brings us to one of the biggest, most debated topics of all: reasoning. Are these models actually using logic, or are they just incredible mimics, just masters at spitting out patterns that sound plausible? So in humans, we often talk about two kinds of thinking, an idea made famous by Daniel Kahneman. You've got System 1. That's your fast, automatic, gut reaction thinking. Then there's System 2. That's the slow, deliberate, logical part of your brain that works through problems. Now, here's what's so fascinating. LLMs are almost exclusively trained on the results of our System 2 thinking, right? All the carefully written books, the articles, the code, all that structured information. So what does that actually mean? Well, it means an LLM isn't sitting there consciously reasoning through a problem. It's just generating a sequence of tokens that looks like reasoning because that's the pattern it learned from all that human text. When it gets something right, it's because the pattern matches up with logic, not because the model understands the logical rules themselves. This is why for a long time, models would fail at really simple stuff, like counting how many R's are in the word strawberry.
And that actually leads us perfectly into our next topic. What happens when they make mistakes? Now, we've all heard this term, right? AI hallucinations. But is that really the best word for what's going on?
I mean, when a person hallucinates, they're usually seeing or hearing something that just isn't there. But when an AI confidently just makes something up, it's doing something a little different. And there's actually a much better word from human psychology that describes this.
And that word is confabulation. Now, this is a term from psychology, and it describes what happens when a person, without knowing it, creates a false memory or a false explanation, but they genuinely believe it's true. It's not a lie, it's not on purpose, it's just the brain automatically filling in the blanks to make a story make sense.
And here's the thing, this happens to us humans way more than we probably realized. The author Daniel Gilbert calls it the filling in trick, and our brains are doing it all the time. So, maybe the next time you hear about an LLM hallucinating, it's worth thinking about how often we might all be confabulating just to get through the day.
Okay, let's move on to our final point. And I would argue this is the single most fundamental difference of all between us and AI. And it's this concept of embodiment.
So, what do we mean by that? Well, it's pretty simple. You are an embodied being. You exist in the physical world. Your thinking is shaped by every single physical interaction you've ever had. An AI model, on the other hand, is completely disembodied. It's just software running on a server somewhere. It can't taste, it can't smell, it can't feel. Look, I know if I let go of this marker, it's going to fall. Not because I've read a bunch of physics textbooks about gravity, but because I have lived with it my entire life. I have direct physical experience. An LLM's knowledge is completely secondhand. It's all learned from text written by people like us, people who do have these embodied experiences, and that is a huge reason why they often lack what we'd call basic common sense.
So let's just pull it all together. Even though AIs and human minds can sometimes produce things that look similar on the surface, what's going on underneath is fundamentally different. I mean, across the board, from how we learn and process things, to how we remember, how we reason, how we make mistakes, and ultimately, how we even exist in the world.
The bottom line is, they are just not the same kind of intelligence. Humans bring meaning, we bring context, we bring real, genuine understanding. AI brings unbelievable speed and a massive breadth of knowledge. The real magic happens when we figure out how to combine these two very different ways of thinking. That's when we get the best of both worlds.
So, that leaves us with the real question we should be asking ourselves. It's not, is AI thinking? It's, we know their minds are different from ours, so what's the best way to combine them? That's the real challenge and the real opportunity in front of us.